Hi, I'm Henry Segerman. This is the 15 plus 4 puzzle. So this is a variant of the classic 15 puzzle, where you have tiles in a frame and you slide the tiles around, scramble it up, and then you have to get it back to the original pattern, the original configuration. Here the difference, of course, is that I've jammed an extra 4 tiles in, and in order to make them fit, the frame is now made from 5 2x2 squares, which are hinged together around a central point. And you can, of course, slide tiles around within one of these squares, and when 2 squares are flat against each other, then you can slide a tile across that hinge into the neighboring square. And so you get it mixed up, and then you have to figure out how to unmix it. You're probably already noticing that there's some interesting things to do with the orientation of the tiles. As you move a tile around that central vertex, it can get rotated. Here I've removed most of the tiles to illustrate this effect better. The technical term here is holonomy. So we start here with 12 and 13 next to each other and the same way up. And as I move the 13 tile around the central vertex, it picks up this holonomy, which results in a rotation relative to the 12 tile. And this is related to ideas of curvature. So there's sort of a point of negative curvature here in the center, and when you take a trip around that point, you come back rotated. This effect of holonomy is also why we have dots under the 6 and the 9, so that you know that your 6 is not an upside down 9, and also a dot under the 8, so you know which way up it is. If you want to get one of these for yourself, they're available on my Shapeways store, link in the description, with some assembly required. There's a painting, of course. I used acrylic paint. And you'll also need some 8mm long M2 nuts and bolts for the hinges. This is the set that I used. I'll put a link for that as well. Okay, now I'll say something about the design. First of all, how come the tiles don't come off? How are they held onto the squares? So they each have a sort of mushroom foot on the bottom, which goes into the rails on the squares. The rails have little overhangs which grip onto the foot. Second, why are there these big gaps between the tiles on neighboring squares? The reason for these gaps is that when you fold the tiles together, that gap disappears. So that gap is necessary for the tiles to have enough space that they can actually coexist next to each other. In order to sort of reduce that space as much as possible, you want the height of the tile to be as close as possible to the axis of the hinge. Unfortunately, of course, the hinge here is made out of these little bolts, and that has some height, and the tile needs to clear that bolt in order to be able to slide over the gap. So this was sort of a tricky problem, and part of the reason why the foot and the main part of the tile go either side of the hinge is to try and keep that as small as possible, that difference in the position of the tile from the axis of the hinge. Because of the requirement that the foot and the main part of the tile have to be either side of that hinge, the bolts can only be very short, so that when the tile slides past, the foot has to clear the bolt entirely. So the entire object is really sized to these bolt sizes. There's also, you'll notice, no bolts in the center. Here's an early prototype of this the 15 plus 4 puzzle, which had bolts in the center as well. And, well, it was a little bit more robust, but it's not really necessary. And obviously it makes it much, much larger because the tiles have to clear all of these bolts in the middle. There are a few other differences. So first of all, the spacing between the tiles. We had the same gap across the hinge and between different tiles on the same square. And this was sort of annoying. They kind of slip down under gravity a lot more than they do when they're tied on each other. One further difference between the prototype and the final version is that the geometry of the foot is a little more complicated. So the foot has sort of 4 legs coming out of it, and the grooves in the squares have extra geometry as well, and that really stops the tiles from rotating in place. This was really necessary when the tiles weren't up against each other. Here in this puzzle, they do stop each other from rotating. If you try really hard, there are certain geometries where you can get them to rotate when they're not supposed to be able to. But the savings in the size of the puzzle and therefore the cost, I think are worth sort of allowing that little bit of extra cheating. So are there ways in which the engineering could be improved in some future version of this? So I already talked about the rotation issue. Another thing that's a little bit annoying, but I don't really know that there's anything that can be done about it, is that if you have a tile which is halfway over a hinge, then it sort of stops the rotation. I guess it's not a problem if it's in that orientation, but if you're here and you're trying to do this, it gets a little bit jammed. Again, I don't think there's really anything that can be done about that, but if somebody has an idea, I'd be very happy to hear about it. Finally, let me tell you about some of the stupid mistakes I made whilst working on this project. So first of all, here are two squares with ugly white splotches on them. The die hasn't worked properly. So how did those splotches get there? So when you order something like this from Shapeways, it's most cost effective to arrange a bunch of them together and then put a plastic wire that goes through them. The reason for this is that it saves on Shapeways labor costs if there's fewer parts. So rather than having 5 of these squares, you have the 5 squares wired together. That goes through all of their processes like that, and then when it arrives to me, I just cut the wire and it's cheaper all around. And the problem here is that I had made the wire too short. So there was no way to clean properly all of the plastic dust out from here, and the die couldn't get in, and so that's why we've got these ugly parts here. Now, why was I ordering 2 of these squares rather than 5? The reason is because in a previous order, I had got these. These squares look fine. It looks like they work no problem at all, but the problem is that they're incompatible with all of the other ones. They're in fact mirror images. How did I come to make that mistake? Well, again, when you order these things, you want to put them in a stack and then put a wire through them. And so what I had done is I'd sort of got my one good square and started arranging the geometry for the other 4. And I thought the best way to do that would be to reflect these across a plane like this to make the other copies, not realizing that by reflecting I would be making incompatible versions of the squares. So the first time I ordered this one, I had 3 of one handedness and 2 of the other, and so that's why I had to order an extra 2, which initially had bad dyeing, and then finally I got the 2 that I needed to make the final puzzle. So if you've made it this far, thanks. This is the 15+4 puzzle. Thanks for watching.